Hey, thank you for joining the December 12th, 2019 VOLTA call. Just a reminder to everyone that these meetings are public and recorded, and we post them to our YouTube channel, so be mindful of that during discussions and any presentations if we should have any today. So we have a few topics on our agenda today. I think we're going to start with discussion of the planned release for December 17th, which is next Tuesday. So let me go ahead and switch over to Jira. And Zach, do you want to go ahead and kick off that discussion?
Sure. So the gist of this is that we wanted to try and make sure that, or because the release is going to happen next Tuesday, that we wanted to classify the work that's being done either into work that we think is going to make it into that release, or that's going to get deferred to the 2.3, which is scheduled for next year. So, Julie, could you go to the I think the releases section?
Yeah.
And click on the 2.2.
Give me a minute here. Apparently, it got me logged out.
And I did notice we have had a couple more people join, so we can perhaps do those demos and things we were
Okay.
expecting to.
And let me make sure my screen, I think my screen's still sharing here. So let me go back to see who's got on the bridge. Okay, so Ganesh, I see you're here. Are you ready to do the demo?
Yes, Julie, I just joined. I'm sorry for joining late. There was a breakdown on the internet. Yeah.
No problem. So let me go. If you're ready, I can give you presentation rights. If you need another few moments, just let me know.
Yeah, just give me 1 minute. I will be ready.
Okay.
Yeah. Okay. Yeah. Please give me the rights. I will present my screen.
Okay. You should have them in just a moment.
Yeah. Okay. So shall I start?
Yes, please.
My
Thank
screen
you.
is visible? Yeah. Okay. Great. Yeah.
Yes.
Yeah. Okay. Thank you, Julie. And first of all, I apologize for the delay, and I'm ready to present my screen. And I'd like to show, demonstrate some work we have done recently on Kafka Topic Exporter, and we have a lot of things done on Redfish area as well, right? So in Redfish, HCore team have worked on PSME module to add some support for retrieving some of the parameters like laser bias current, temperature, TX power, voltage. So this work has been done, and I have a system now where I run this. Okay, this is my OLT. So on this OLT, I have a PSME REST server, which is built by using the code, using the source code from Redfish. Sorry, the PSME code from HCore, and this supports now the additional parameters which we can retrieve using the Redfish APIs. So let me just run one command to hit, and we can probably observe. So I'm doing this from my local machine. So from my local machine, if I hit this API, the very first line here, I get this data. Let me just open it in better format. Yeah, so this is the this is the data it returns on from the device using Redfish API. And here, if you look at this, we find the transceiver statistics where we have bias current, we have TX power, we have voltage, and we have temperature. So this we get using Redfish on OLT. OLT is the device. So this is my OLT, and this is the IP I have connected to, right? So on this IP, I am putting like, yeah, I'm hitting the command, hitting the API, and I get this output. This is manually I'm doing. Now these parameters are pushed to Kafka topic by, there is another module called device management. So again, HCO team have worked on this particular component, and this is ready. So here in this Siba setup, this is Siba in a box setup, but we don't have all the pods. etcd and VOLTHA pods are missing here. We don't need in this demo, so I didn't install that. But these are some of the pods which are running here. And device management is the one we can probably see. Yeah, it is there. It is running. We don't see any message here. And this is another component which is KPI exporter, that is Kafka topic exporter. So there is no message on any of the topic. So we can see importer, ONOS, KPIs, and PPOE stats, and ONOS AAA, and VOLTHA. So these are the 5 topics this exporter is looking for messages on. So right now, the importer is the topic on which this device management should put the message. And once we get the message on this importer, our Kafka topic exporter will publish the result. So here, yeah, let me just do something. Yeah, this is the exporter. I just want to get this. I'll just go into the Kafka topic. I'm just trying to. Okay, if I, yeah, here if I try to run the command, let me just see if I can consume some of the messages from this topic. So I don't have any message in this particular topic exporter, sorry, importer topic. So what I'll do is I will probably produce some message manually, and probably that will that way we can just check how these parameters will be displayed on the importer log, sorry, exporter log. So here, right? So let me just pull out this command. I have already, to save time, I can just copy this command from. Yeah, I have some. Yeah, I can just publish this using producer. That will be easy. Sorry. I'll use here. Kafka producer. What is the name? Console producer. Yeah. So here, now if I put this message, the one we have retrieved here just some time back. So I'll just copy this just for simplicity. I'd just like to show the first, show you about the message, how it retrieved. So here we have those parameters, and the moment we put it on the on this topic. So this is just an info log. So I put one log just for our understanding about these parameters, where we can see the laser bass current and temperature and px power and voltage. So this is not the support currently we have. And now after this couple of things, one is the device management and PSME changes, and then exporter changes, we would be able to get these parameters on Prometheus and Grafana. So today I have not configured Prometheus, but now since we see these parameters here with the exporter, so it will be available on the charts on Grafana. This is manually I pushed a message on importer topic, but the same thing can be done using device management. So here the HCO team is one who knows end-to-end about this particular component, but I have a couple of commands to just understand how we can configure this particular device manager to get the messages for a particular device. So currently this does periodically, it will hit some of the APIs which is configured, and the moment we see this working, so those messages are put on this particular topic. So that's the reason I have configured importer as a topic, and from importer we could retrieve this information. So yeah, this is briefly, I just wanted to show how the exporter will be in a position to get these additional parameters which we have been working for some time, and a lot of effort are put by HCore for PSMA module, and then exporter will publish this to Prometheus and Grafana.
Yeah, thanks, Ganesh. Yeah, I think this does show, had the message been on the Kafka topic, that the exporter would have grabbed it, would have properly interpreted the values in it, and would have pushed it to Prometheus. Just a question is, whatever went wrong with no messages flowing from the device, that's just something went wrong in either the importer or the Redfish on the device itself, or something down at that first step that we didn't get those automatic messages that we assumed would be flowing. Is that right?
You mean if any invalid message or any message where we don't have these parameters?
No, I mean that in normal operation we would have, rather than you having to paste the message in to demonstrate it, we would be expecting messages to just be flowing right now.
Yeah. Okay, got it. So those messages are pushed by device management here. So I can probably show you in another couple of minutes how these messages are pushed onto the topic, and in right here we can see how we can use this to observe those messages. So let me just start this component here. I have let me open another terminal, and I can probably I'll use this. Yeah, we have the device management pod running, and I have built this particular module here in locally, and I'll just go to demo test. So these are the steps Dinesh helped me to run, and once we have this, I can probably use this this particular executable. So they have created one demo system. So in this, we can see that message, but let me open one more terminal and let me run, let me configure the device. So that's important. Let's say I have a device. Let me just run here. And if I have the device, I can simply run the CLI to configure that. Device management and demo test CMD. Yeah, here we can provide, we can subscribe a particular device. So this is manual, but probably HCO team might have worked more about this to make a little more automation. I don't know why it is saying device not registered, but let me attach, fail to subscribe. Okay, maybe I have subscribed once in past. I don't see messages. Yeah, so here, this is removed and alert. Okay, that's fine. But still, I think if you wait for some time, couple of minutes, so it periodically hits the different APIs. So probably I can show you if I have something in past. So it will hit different APIs. So there are multiple services they have configured. For example, here, this is the Ethernet switches. So Ethernet switch is one, then chassis is another. So continuously it keep on hitting the different APIs, Scott. So this is the importer, this is the device management module who is responsible to hit those messages once we subscribe these devices. So this device IP is the OLT IP.
Okay, thanks a lot, Ganesh.
Yeah,
I think that provides some additional context for how the system is configured and how a device would be added, and then at some point we would expect messages to start automatically flowing from the importer through the exporter. Yeah, good.
Yeah, right. Yeah, this works actually. So maybe I have configured already one device, so that could be the reason. But this is working. I have already tested, and maybe there is some more automation needed here, and HCore team might have been working on this. So maybe Dinesh, if he's on call, he can provide a little more information. But this is the end-to-end flow where device management will help to retrieve the PSME information on the Redfish from any number of devices which we configure using this CLI. So is that fine, Scott? Is that answered your question?
Yeah, I think that's great. Thank you, Ganesh.
Okay, yeah. So yeah, that's it. I have planned for today. If anybody has any question, please let me know. Okay, then yeah, that's all, Julie. Thanks for the time slot, and so these things will be pushed soon, and it will be available. So some part of it is already pushed, committed, and a little bit stuff is pending, so which I'll commit this week, and it will be available next week onwards. Yeah.
All right. Thank you.
Okay. Yeah. Thank you.
And I believe I've taken presentation rights back, and
yeah, sure.
then. Matt, I believe I saw you online as well.
Yes, ma'am, I'm here.
Okay, then would you like me to give you presentation rights for the discussion on the MIB upload template design?
Sure.
Okay, you should have them in just a moment.
All right. You guys see my screen?
Yes.
Okay. So real quick before I start, folks don't already know many of the design documents for some of the items we come up with in VOLTHA are available in this Google Drive docs folder here. And specifically some of the OMCI and ONU work we're looking at, you'll find here as well, including this presentation. So starting off, as we begin to scale up our ONU count from tens to hundreds to 1,000, we start looking at some of the tasks that we're running, some of the initializations that are done that may be redundant or may be duplication of a lot of effort, which kind of brought about this notion of a MIB template for ONUs. For those of you who don't know, the MIB discovery process is codified in the ITU G984, 988 documents for the mechanism in OMCI to discover what hardware capabilities exist in an ONU. This is, not only uniports, this includes TCONs, this includes queues, and other, various identifying elements needed for provisioning later. This discovery process is needed for, obviously, the subscriber flow provisioning time for us to actually assign the right IDs to the right queues, to the right TCONs, so on and so forth. If you would like some light reading, I recommend checking it out. Otherwise, you can just take my word for it. This process typically is called the MIB upload next process. This is an iterative process where the OLT, and the OLT in this case is VOLTHA, asks the ONU for its MIB, for its database of configuration. And in response, the ONU tells the OLT, these are how many elements you need to query for in the MIB upload next sequence in order to successfully have downloaded the MIB from the ONU to the OLT. I figured also while I was doing this, it might be a good time to kind of review the ONU discovery process in general. Kind of some of these elements have existed since VOLTHA 1 and were never really presented, and I figured it was a good time to maybe show a bit of a sequence diagram of how an ONU starts up from nothing to initial MIB downloaded. And that gets us to our venerable and often maligned reason. And what does it mean? Some of the MIB download process is intertwined with the reason update, so I figured it would be a good time to kind of show some of this. This sequence diagram here is the beginning point for when an ONU is plugged in and powered on. This is, from its inception to the moment it's plugged in, powered on, and then the discovery indication via the OLT adapter works its way through the OLT adapter, child device created, core calls adopt device, ONU adapter is finally, its handler instance is created, resulting in our first reason code, our activating ONU reason. And you'll notice at this point also the ONU adapter invokes OMCI, the Open OMCI library for the first time, creating the initial devices needed, or the initial objects needed for using the library. At the same time, when the ONU is invoked through the child detection process, the OLT adapter also reaches back out to the OLT hardware to say activate that ONU, which in PON speak really means set up PLOM, set up ranging, actually set up the initial ALEC needed to perform OMCI. This successful PLOM setup indication comes back from the hardware as an ONU indication versus just an ONU discovery indication to the OLT adapter. OLT adapter then proceeds to send an inter-adapter message to the ONU adapter saying basically to start the OMCI process, start the state machine for MIB synchronization, MIB discovery, and subsequently later actions. A lot of any of the OMCI work at this point hasn't actually started yet, but I felt this was worth showing because there's usually a lot of contention and a lot of synchronization that goes on with this process. And many times the only clue to what's going on is kind of seeing these reason values. But in working through it, up until this point, this moment right here, when the start function is called on ONU, Open OMCI ONU device, is when the actual OMCI transactions start, which is really the bulk of what we're talking about now, which is the discovery loop. So this is kind of just a continuation of the previous one with a few more of the guts of Open OMCI shown. When the ONU adapter tells the Open OMCI device object to start is when it kicks off the state machine within Open OMCI called the MIB synchronizer. MIB synchronizer proceeds to seed a new database for that device, add that device, and kicks off Open OMCI tasks to perform various actions throughout Open OMCI. And in this case, it's the MIB upload task. This MIB upload task and the green section is really the focus of this design and this template idea. When the upload starts, this sequence here represents from the upload task all the way to the OLT adapter, all the way via the agent to the ONU, an OMCI transaction and an OMCI response, being paired up by the transaction ID. In the previous slide, when we mentioned MIB upload and MIB upload next, the number of commands returned by MIB upload, and in this case, it could be 200, 300, maybe even 400 commands, is the instructions to the MIB upload task to how many elements it needs to go query. This green section, this loop here, and all of this messaging has to take place 300 to 400 times, request and response, for the MIB to be successfully downloaded. And as I'm sure many of you are aware, this process can be very time consuming, and it depends even on the ONU hardware. ONU hardware with more queues, with more Ethernet ports, this process will take longer. The idea here is for a particular ONU make, model, and software version, for common ONUs, many elements that are discovered in this process are identical. We could have 1,000 ONUs, each with the same hardware equipment, software versions, and from an initialized state where nothing has been provisioned, especially after a reset, which is, I didn't indicate here, the first command that's sent from the OMCI library is a reset, basically clearing out any old config. That configuration is mostly identical. So for 1,000 ONUs, we've repeated the process many, many times. We're getting the same results over and over. After this process is finished, just kind of real quick going through it, this is the MIB synchronizer is done. Everything is in sync. The ONU's database, the OLT's database, or in this case, OpenOMCI's database, is in sync. And the reason discovery MIB sync complete is sent. This is where, at this point, now we are interacting with the core, again, in regards to querying for the Ethernet ports, the UNI ports, querying the local database, right? We've learned the database, now we can use it. And using those results to create ports in the core, and then to proceed downloading what we call the initial MIB, which is kind of an ONU global set of configuration, setting up the bridges for each UNI ports, creating the GAL managed entity, nothing subscriber specific, nothing priority queue specific, but pieces needed to kind of get the ONU ready for later provisioning. And again, it uses the same back and forth OMCI inter-adapter messaging that the other tasks use, the MIB download task being just another OpenOMCI task. Once this exchange of initial MIB downloading is finished and ports are created with an inactive state, at the conclusion of the MIB download task, we inform the core that the ports are active and the device is active. This is the amount of time from plugging in the ONU to reporting to the core that this device is ready. At this point is when the device is actually ready to receive flows from ONOS. It's advertised to ONOS as an enabled set of UNI ports, really. But everything in this sequence up until now was really just the initial getting the ONU on board. When I said earlier, again, this is a lot of times after we plugged in an ONU of the same type, you know, an Istratel or an Alpha, many pieces of this are already the same, mostly the same. There are pieces in there that are unique, certain hardware identifiers, equipment IDs, MAC addresses, but those end up being fewer than you would think. Many of them are one or two managed entities, specifically around, again, like hardware that are unique. But the most part, the big spend is spent, again, iterating over all the queues, iterating over all the TCONs, iterating all of the initial blanked configurable elements that we just need to know what they are. And again, for hundreds of ONUs, this is a lot of wasted time and effort. We're doing things that we've already done 100 times. Why are we doing it again? Also, from a planning point of view, ONU types typically on an ODN are known ahead of time. We don't typically plug in brand new ONUs out of the blue and unexpectedly or expectedly, without a lot of planning ahead of time. We typically choose ONUs ahead of time. We know these are the 5 or 10 or 20 that are supported. They get tested. They go through labs testing, interop testing. So these are a known quantity. These ONUs and their software versions are tested ahead of time. Again, moving towards something we already know. The idea here, the design, is really creating a template of these discovery results, this iteration that's been done for these ONUs, and using a matching criteria of a software version, a hardware model, an ONU make, using these things combined to synthesize a key to look up a template. And if it matches, if we know that what we have queried initially matches what's in our template database, we can go ahead and populate that MIB database, that MIB learning, without having to go through the iteration of 300 or 400 OMCI round trips to learn it all again. The implementation for this looks a lot like, again, any other task. This would be the creation of a new OpenOMCI task, the MIB template task, that would run from the MIB synchronizer state machine, similar to MIB upload and other OpenOMCI tasks. The keys for this task would be initially, before even asking for MIB upload next, but after doing a reset, asking for the ONU-G, ONU2G, and the software image managed entities for unique identifying characteristics, the vendor ID, equipment ID, and active software version. Using these managed entities, we can look up a preloaded template in the key value store that matches the MIB. And in this case here, you can see it's in the tree format of a vendor ID, equipment ID, and software version. So we can have multiple templates for multiple vendors, equipment IDs, and even software versions if needed. And then just a couple of examples of some of that data that I pulled from a couple of ONUs we've tested with in terms of the equipment ID and the software version. Yeah, like I said, this match is used to preload the MIB and fast forward to the MIB discovery MIB-seq complete state, saving, again, number of iterations and a lot of messaging across interadapter and Kafka for things that we already know. At the same time, we don't want to limit ourselves either. So for any ONU that do not match any template, that is a new ONU that we truly want to try out for the first time or have some sort of limited field trial, it proceeds through the MIB upload and discovery task like it does today. No reason to remove that. And again, with planning, there shouldn't be too many of those out there. There shouldn't be hundreds of thousands of those all of a sudden. But as time goes on and we learn more about new ONUs and we want to expand them into the greater network, templates can be created for them and they be preloaded. This here, again, is just a sequence showing the new state machine, the new sequence. The blue section is the MIB template task, the new one. Much of it is the same. We're still seeding database. We're still adding it. We're still running the task. But this MIB template task is run first, and the green section is only run once, asking for only the 3 managed entities via OMCI that we need to then later look up the template and then assign it. Again, and then jumping ahead to MIB discovery complete. And if for whatever reason, again, if it doesn't match, then we proceed back to the previous sequence through the MIB upload task, which is the 300 or so walk and learn mechanism. And that's it. I was going to real quick show, again, for illustration purposes, just a Wireshark capture that shows this back and forth. The MIB upload ask 339 items to go get, and then proceeding through each one to going and getting all of them. All of this that you see here that I'm scrolling through would be saved. Yeah, again, priority queue, you see those repeat many times. The traffic schedulers as well. All of this would be saved in terms of iteration and messaging. If anybody is curious, I also have these sequence diagrams as PDFs in the design documents folder for reference or for any help if you needed. Also, the ITU document, if you, again, would like some light reading, it's uploaded as well, and it also goes into details on the synchronization and audit process that has been defined in the specification. And that's it. Questions, comments, concerns, criticisms?
So Matt, just to make sure I'm following correctly, this reduces what would have been 300 messages down to just about 3 messages?
Correct.
And that, I'm just wondering how much that improves the speed of an ONU coming up. It seems like that would be considerably faster and less resources, particularly when like 1,000 ONUs are all coming up at the same time.
Absolutely. This is exactly the target for that scenario. Again, the blue section here, well, not this one, this section right here, this looping, every single ONU is going to go through this. And as you can see, OpenOMCI is involved, OLT adapter is involved, the gRPC to the agent is involved, and then the ONU itself, right? 300 times for every element. And again, and then also, once we finally go back to persisting our MIB database, there's this set here, actually writing to key value store. Again, another element of latency there in terms of having to write to the database 400 times in terms of learning what you've learned. This is again attempting to save on all that messaging.
Matt, would it have to go through the same sequence on the disable and enable again?
No, good question. So the great thing about this database and OMCI is there is this notion of and I can probably even find it in here, this notion of a MIB data sync attribute. What MIB data sync does is it allows you, once you've synchronized your databases, both the OLT, VOLTHA, and the ONU have a counter, a MIB data sync incremental integer, that any subsequent provisioning after you've done your learning, where the counter starts at 0, both sides increment their side of the number. The spec says as you perform your provisioning, both sides should continue to stay in sync by virtue of remembering or counting at the same time. When an ONU is disabled, enabled, when an ONU is unplugged from the fiber, or when the greater ODN is unplugged from the PON and plugged back in again, the OpenOMCI MIB sync process first checks this MDS value for each of the ONUs, and it's a single get. And if that MDS value still matches, whatever that is for any one ONU, if it still matches what we've remembered, the MIB immediately moves back into the in sync step. No need to have to sit there and go through the discovery loop again. If it does not match, then it's assumed something's happened out of band while we were gone, or maybe the ONU is restarted, physically powered off and powered on. Then at that point, the MDS values would no longer match, and we'd have to start over with a discovery process. But here with the template as well, it would still apply in terms of an ONU is restarted. We know it's been restarted. We have to start over our synchronization process. If it's a known ONU, we can still jump right ahead to reseeding the database from the template and then jumping to MIB discovery or MIB in sync.
That's pretty cool. That's great.
Yeah, this kind of kind of gets us back to somewhat like in the older VOLTHA days where a lot of the MEs were hard coded. It was of course very fast because you didn't have to learn anything, but again, it made it very limiting in terms of what you could do. So we're kind of like, okay, now we have all of this flexibility with the library, but we still need some of that speed. So trying to bring some of that back.
These templates, they're added manually?
Yes, this would be loaded much like the tech profiles themselves on VOLTHA creation times or at service provisioning time. We create a tech profile JSON document that describes the various services, voice over IP or multiple classes of high-speed internet or video. At that same time, presumably, you would also say, oh, and these are also the ONUs that I'm going to allow on the network, or I'm going to have prepared the network for in addition to this tech profile. Presumably, they would all need to work together anyway because we can't create tech profiles for numbers of queues that ONUs don't support anyway. So they kind of go hand in hand in terms of pre-provisioning of service.
Cool. Thank you.
And I guess that's it for me. Anybody else has any questions or comments? I'm easily found on Slack or on the mailing list. And again, the VOLTHA Docs, Google Docs Drive is a great place to go and see kind of some of the new things that are going on and some of the ideas that are being put together. And with that, I'm finished.
All right, thank you, Matt. I'll go ahead and take presentation rights back. Okay. All right, Ganesh, Matt, thank you both for the discussions and the demo today. And then lastly, I think for today's agenda, take a look at the planned release of VOLTHA 2.2 on next Tuesday, which is December 17th. Let me go back over into Jira. Okay, and Zach, are you still on the audio bridge?
Yes, I am.
Okay, so I think you were starting to walk us through some comments before we went into the demos.
This dashboard is up. It basically just goes over how many items are still in progress or to do for the 2.2 release. This is just the VOLTHA side. There might be some SIVA components there, but it looks like we have about 72 issues that are either assigned or in flight for this. If you look at that first two-dimensional filter statistics. So there's 28 that are still marked to do, 44 that are in progress. And then I broke it out by the epics, so that roughly match onto the brigades. So it looks like most of the things that are still in to do, like the vast majority, are either unassigned, they have none as an epic link, or they have their maintenance or test automation. Those are that makes up about 50 items. So it would be good to go through those and figure whether they're going to make it into this release. If you scroll down a little bit, you'll see that there are, these are the unresolved items. We have just a few that are still that are still in that are high priority. There's and a lot of them have been touched recently. If you look at the high priority ones, they've been updated recently. We also basically to the community, this is just a sort of an update that get in there, get into Jira, and either move things to 2.3 or get patch sets in. We don't. This doesn't monitor whether you actually have a patch set if something here is in progress in Garrett that fixes this. But just please update your status in Jira.
Thanks, Zach. Any questions from the group? Okay, and then I thought we had done some cleanup, so I'm surprised to see so many that were without Epic. So I'm wondering if some of these are subtasks or tasks. So I'll take a look at that.
Yeah, if you click on those, it will.
Yeah, it'll pop them up here.
It'll pop you a filter that goes over that.
Okay, some of
them are. It looks like some
new.
Are epics.
A couple of them.
So epics don't go into epics. So.
Nope. So we're probably in better shape than that looked. But it looks like some of them are tasks. Some of those have, if they're subtasks.
Yeah, if they're subtasks, they don't get assigned.
Inherits it. Yeah. So I'll do some double checking there after the call. But for the others, most of the in progress, I've been leaving those in 2.2 unless I check with someone that they say that nope, definitely not going to be in 2.2. Then I'll move it to 2.3. The to-dos, I've been moving a number of those over, as have others in the group. Okay, any other code-related issues that we want to talk about related to the upcoming release? Anything related to code freezes potentially, or other topics that we should bring up on today's call?
So is there a Jira task for someone to actually make a release on release day? And what will that release encompass? Are we tagging all VOLTHA components with release versions? I guess just what does this release mean to us on the 17th?
That's a good question, Scott. I don't think we've specifically said that, but tagging all the components and updating the Helm charts would be what would need to get done, I believe. I will make a ticket for that.
Yeah, sounds good.
Thanks, Scott. Thanks, Zach. Any other questions or comments? Okay, I am not hearing any. So then lastly, I'll just make a couple comments. So I am out of the office starting next week until January. Next week, Zach's going to be hosting the meetings in my absence, and so you'll be seeing any agenda notices, and he'll be hosting the bridge. That'll be coming from Zach. And then I believe the week after that, at least, we'll be canceling the meetings because many folks on the U.S. side will be out of the office, believe probably through the end of the year. Are there any plans to have on the ONF side, are you guys around on the last week of December, or should we cancel those meetings as well?
I believe the first meeting will probably, so we'll have a meeting on the 17th, and then the next meeting will probably be January 7th.
Okay. January 7th. Okay.
That's the Tuesday meeting.
Okay.
So Tuesday the 7th and Thursday the 9th would be the next VOLTHA meetings.
Okay. So we'll go ahead. I'll kind of capture that. We'll get the updates on the court calendar, but if you are still working for next week, please attend the Tuesday call with Zach. And I think that's it for what I had to discuss today. Any other topics that we'd like to bring up with the group before we adjourn? All right, I'm not hearing anything, so I think we can go ahead and close today's meeting. Thanks, everyone, and I will talk to most of you next year, and then hopefully everything will progress well going up to our plans for a interim release or the 2.2 next week. All right, with that, I'll stop the recording.